All right, let's start. Welcome. It's so good to see you tonight. Just looking at the names, I realize it's an incredibly diverse crowd with people from all over the world. That's fantastic. My name is Josep Grau. I will be the chair tonight. I'm the Deputy Director of the Institute for Sustainable Heritage and an Associate Professor of Heritage Science at UCL. We are here at the UCL UCL ISH guest lecture series, which is part of the ISH Academy that also offers training courses and other events. I'm very happy today to introduce Katrien Keune, but before I tell you about her CV, let me explain a little bit how this works, even though by now we are all very used to this kind of online talks. So the talk lasts for 1 hour. We will have approximately 10 to 15 minutes for questions in the end. The way you submit questions is by writing at this button that you see at the bottom of your screen that says Q&A. I receive the questions and I will read them aloud to Katrien in the end. And I would be grateful if when you write your questions, you could also mention the institution you work for, if that is applicable, because sometimes it helps the speaker know where the background of the question is. That said, let's begin with the presentation of our speaker. Hello, Katrien. Katrien is a chemist, head of science at the Rijksmuseum in Amsterdam, and professor by a special appointment of molecular spectroscopy at the University of Amsterdam. The science department, a sub-department of conservation and science, conducts research on the Rijksmuseum collection in close collaboration with conservators, curators, and technical art historians. Keune is specialized in aging and degradation of studies of pigments and oil paintings at the micro and molecular level. She initiated and co-led many national and international interdisciplinary research projects, including now the GoGreen project. The project that it's running at the moment is attracting a lot of interest, and we are going to hear more about it. Several projects on infrastructure. Katrien has been one of the masterminds behind the current success of the European infrastructure for cultural heritage, for heritage science. And she's also going to talk to us today about the scientific research of Operation Nightwatch, the largest research project on Rembrandt's well-known masterpiece. We are looking forward to your talk. Katrien, over to you.
Thank you so much, Joseph, for the kind introduction and also the invitation to speak on this topic. And small disclaimer, I won't speak about Operation Nightwatch, but I hope to give the context why we do research to preserve such big paintings as the Nightwatch by Rembrandt. And the topic is indeed preservation of paintings towards a sustainable future. I'm fully aware that it's a very broad topic, and I'm sure I'm not inclusive, but I hope to give you a little bit idea what we are doing within the GoGreen project in general, and more specifically, what type of research we're doing within Amsterdam to get a better understanding of how we can preserve paintings in a more sustainable way. So what can you expect this /afternoon evening? I hope my slide is, yeah. I will speak a little bit about sustainable art preservation and then ongoing activities like the GoGreen project. The core of the lecture will be on oil paint research, what is subdivided in complex heterogeneous systems, preventive conservation, remedial conservation, and then finalize on what we think is green or how we should define green parameters for conservation. But let's start. Can art help save the planet? Well, if you mention to colleagues about sustainable conservation in heritage, I think they directly mentioned something about the reduction of energy consumption in museums, which I think is completely right. But I think there's an other side of putting art and art conservation more centralized in the discussion of climate change. To preserve our planet for future generations, we need a cultural shift and a more consensuous way of living. And I think it's important to appreciate what we have. And to give an example here, if we appreciate a forest, we will take better care of it. And this also applies for art. So art nurtures the perception of value and is a treasure for our feeling. It's also an essential part of our well-being. So therefore, it's important that we take good care of art. So making conservation field more sustainable and greener and sharing this with our audience, I dare to say that conservation of art contributes to the conservation of the earth. So how to make conservation field more sustainable and greener? And of course, there is no recipe or a road or a pathway how to get there. But last year, with a consortium of 14 institutes, we launched a manifesto that outlined 10 key actions for the conservation and treatment of cultural heritage. And the goal of his manifesto is to foster a sector-wide consensus by implementing measures that are in line with the objectives of the European Green Deal. And here you see the manifesto, and I'm afraid it's difficult to read, so I will quickly read the 10 points we defined altogether. And you can find them here on the website on the slide. The first one is we all contribute to the greener movement. The second point is a shared definition of greenness is our foundation. 3, scientific evidence support good decisions. 4, measurable targets help us reaching our goals. 5, becoming greener means innovative in our practice. 6, research takes time and money. 7, sharing knowledge is crucial. 8, educating our community is empowering. 9, greenwashing has no place in conservation. And 10, heritage engages society. And of these 10 action points, I will highlight especially point 3, scientific evidence support good decision, what is a red thread in this presentation. Of course, there are many other initiatives, and I'm definitely here not complete, and I think you are also involved with initiative on a local, national, or global level to make conservation and conservation heritage more sustainable. I just took here some screenshots about website of our larger organizations like ICROM, who have a lot of activities, and ICOM-CC and IIC with conferences dedicated to the topic, or other organizations like Key Culture or ArtSwitch, who have dedicated their task to get conservation more sustainable. So just to be aware that a lot of activities worldwide already are ongoing. But what we have in the Netherlands, and as Josh already mentioned, our work in the Rijksmuseum, we already since 5 years have several actions ongoing to make the museum more sustainable. I think last year we replaced all our central heating with heat pumps. So we got a 90-70% reduction of our gas consumption compared to 2019. So we are almost 100% gas free. And we replaced all lights to LED lights, and we separate our trash. And we also, with exhibition, recycle all exhibition materials as much as possible. But if we look to the climate, what indeed is correct is the most energy consumption in the building. We also try to make more efficient in our climates. So what we have done, we are running several pilots where, for instance, here at the lower part, we turn off the heating system off during the night to reduce energy. We went from relative humidity to absolute humidity measuring, so it really has a major impact on our climate system. So we don't control every time the RH is high or low. You don't blow directly cold or warm air into the museum. So it's a much more smoother way of detecting the boundary conditions. And this summer, we will also do one pilot test to go to wider our climate conditions to the BISO guidelines. So having a range from 16 to 25 degrees and a relative humidity of 40 to 60. And when we start this pilot, we parallel also to monitoring our collection to see is there any impact of the release of these climate conditions on the collection. And secondly, we also place some sensors to see can we monitor it. So we, although this is a very difficult task, we also are taking care of our collection to monitor if there's any effect. So this is to illustrate that we're doing different ways to reduce energy consumption, but keeping aware our collection. There are funded by the European Committee, there are several projects called the Green Heritage Cluster. And one of these projects started in 2022, where 3 projects were granted. One is a GoGreen project, where I'm the coordinator of, which I will show in the next slide. The Green Art, what is Professor Baglioni is the coordinator of. And the MOXIE program, what is based in Ghent in Belgium, where they also develop new technologies. And the focus of this cluster is to develop green technologies and material for cultural heritage. And since then, 2 other clusters are started for sustainable and green heritage, which I won't discuss here. I have a slide for each project, MOXIE and Green Art, just to give you an impression. Of course, this is not my expertise, but I just would like to bring it under your attention because they're also doing very important and interesting things in technology development. First of all, the MOXIE, what is standing for Green Atmospheric Plasma Generated Monoatomic Oxygen Technology for Restoration of Artworks. With this atmospheric oxygen, they want to develop for conservators to remove surface contamination. Think about soot, dust, lipstick, other type of surface activities, what they can remove with all type of objects. If you want to know more about it project, I would stimulate you to go to their website or contact them directly. The other project is Green Art, the green inventory in art and restoration. And Green Art poses new solutions based on green and sustainable materials and methods to preserve, conserve, and restore cultural heritage. Topics they cover is protective coating based on green material from waste and plant proteins, foams and packing material made by biodegradable polymers, and also work on consolidants based on natural polymers from renewable sources, bleaching and gels from natural waste. And they also have green tech solution for monitoring cultural heritage assessment non-invasively. Again, if you want to learn more about this project, also visit their website or directly contact the PI of this project. Then we get into the green, a GoGreen project, where I will go a little bit more in depth. The full title is Green Strategies to Conserve the Past and Preserve the Future of Cultural Heritage. It started 1.5 years ago in October 2022 and is running for 4 years. It has 13 partners, as you can see here by all the logos and the photo taken at the kickoff meeting. The objectives of the project are as follows. GoGreen promotes preventive and remedial conservation practices based on green principles to spearhead the green revolution in conservation. We have 5 objectives. One is to define parameters that constitute green conservation to influence the creation of a sector-wide standard. Second, to develop preventive conservation practices and a decision-making model that utilize the green thinking in conservation. So then you get indeed assessment of how you have to make decision-making, including green parameters. 3, to develop and introduce new innovative materials and methods inspired by historical recipes and methods, biological processes and green chemistry practices. We create a digital web app that helps conservators evaluate the environmental impact and their actions and support their search for greener alternatives. And lastly, and I think very important, is that we empower practitioners by creating a sector-wide paradigm shift, making green thinking daily started in conservation, and we do that by developing education modules. And to summarize it, for me helps also is here this scheme, how it's organized. And if you look to the core of the project, we have work package 2, what is dedicated to preventive conservation. 3 and 4 are developing on first remedial conservation, so that is green cleaning methods, and 4 is stabilization technology. 5, I think they put it in the center, where we have new technologies to assess what we are developing. Work package 6 is where we develop an app, and I think what is important to see that this app, if you have, for instance, a conservation method where you say, oh, I clean with a swab with acetone, you fill it in the app, and you get then an assessment of your use of acetone and swabs, and then they give alternative options which are better, are sustainable. So it's not something that what you can do better. It gives you an insight what the methods and materials are using, about how sustainable it is and how green, and they give alternative options in rating of certain parameters. So this is in full development. 7, I think all these developments go into this educational work package, where we develop modules that can implement it in conservation schools. And finally, of course, assessment and communication. I will come back to work package 8 at the end of this presentation. A little bit more in depth what we do in these work packages. Work package 2, what is dedicated to preventive conservation. We develop certain damage functions for limestone, steel and glass, and they are distributed already throughout Europe, where we monitor them and develop this damage function on that. We also develop a damage function for oil paintings, which I will later show you. And in this work package, we also have the development of this decision-making a model for the bigger context. In work package 3 and 4, we focus on the cleaning of paintings and metals, and in the consolidation we focus on the consolidation of metals and glass. So that's are the 2 topics. And I think what is the common theme between work package 3 and 4, that we go really back to historical recipes and to see what can we learn from these historical recipes. For instance, in the past they used to clean paintings with potatoes and bread, or with alcohol or wine. And can we learn from these methods, and can we extract something what is also green and sustainable for nowadays, or where they clean indeed the silver with more soap. We try to mimic or make the soap again to see how we can benefit from historical recipes. Parallel, and that's what you see also with the consolidation, a lot of bacteria and fungi use are investigated to see if we can improve cleaning here. And on the top here, you see, especially with the University of Bologna, is developing more greener gels and tissue what are biodegradable. So in all ways, we try to improve the methodology based on or historical recipes, or indeed green practices, or biological inspired issues. I already mentioned the assessment of these technology for curators, and that is wrapped in work package 5. And work package 5 is separated in 4 tasks, which I briefly would like to highlight to you. Is that in one task that is on the left, we develop computational approaches where we use artificial intelligence to really predict the crystalline of glass. So there we develop an algorithm to predict for preventive conservation, to predict the crystalline of glass. Secondly, we develop new type of monitoring tools for cleaning of varnishes, so mostly using with UV luminescence and also looking with Rembrandt spectroscopy. The third one is more for the consolidation, the impregnation work package, where we use 3D imaging approaches. And the last one, where we try to make a link with these advanced techniques to more the low tech in a conservation studio. So what can we learn from these advanced techniques with the tools we are using now? So how can we stretch these low techniques more, that we get more information out of it? So that is what's happening in work package 5. Getting back to this overview, and of course it's just an highlight about what we're doing, and that we also making webinars where they are going more in depth. So these are also posted by our social media, so that's where you can get more information. What I think is important in the project itself is coming back to this manifesto, the scientific evidence, what we are trying to develop to make good decisions. I think that is what we do, of course, as a field already for many, many years, to really understand what we are doing. So that brings me also with the bulk of the part of my presentation of the work what we're doing in Amsterdam. We try to understand better paintings and how they behave to make indeed decisions. Can we indeed release the climate or the RH conditions, or is it safe or not? Or can I indeed better use acetone instead of ethanol, or vice versa? So that's what we try to investigate in more depth. So there we focus on oil paintings. We'll speak about heterogeneous systems, preventive and remedial conservation. And a quote like this: oil painting as a complex heterogeneous system. That's a little bit how I see oil paintings. And of course, I don't know what you as an audience are, how you see paintings. So I just briefly want to take you along how I see oil paintings. And here you see a paint cross-section taken from the night watch. It shows some beautiful cross-section with dark and underlayer, beautiful red layer composed of red lake and varnish. And when I did my PhD, I think almost 25 years ago, I started with a book on pigments, and I started with a book on binding media to read into the topic. And it turned out that it's such more complex, and that it's much more interaction. And nowadays, of course, that's obvious, but it only shows that in a short period of time, a lot of things, also the thinking how we see paintings are changed. So you have, of course, in heterogeneous systems where you have inorganic material and organic material. What I would like to stress here, and so we'll stress it in the next slide, is that you also have local different conditions. So sometimes you see new products formed on a certain, but can only form on a certain conditions, where in another area, a few microns ahead, let's say in this area, different products are formed. So that indicates that the local conditions in paintings are very locally very different, and you can get different chemistry and different kinetics and different type of reactions. And I think that's why it makes such a fascinating topic to investigate painting, because a lot of things are ongoing. So the takeaway message is that it's very heterogeneous systems where you have different type of conditions that determine the chemistry here. And if you zoom in, and that's also what my colleague Jeroen Hermans is really focusing on. We focus mostly on oil painting. Well, you see on the right the triacylglycerol from the linseed oil or another oil, what is really the basic component. Well, if an oil paint is drying, you get a lot of cross-linking, a lot of polymerization. You do mathematical models, what shows that in the first hours, millions of reactions already taking place when an oil is drying. So it also shows the complexity. But if you zoom in a painting like here, and we just have here a skim how we see these oil polymer network, it's extremely heterogeneous. And we also think, or we also do some lot of tests where you have in a polymer already different network intensity, different density. So it's very undefined, but it determines so much the reactivity here. The next slide, I want to show you that, of course, nothing stays on its place on a certain scale. You see here two cross sections from the nitrodes where here you can see like some mirroring egg, but here these products have formed inside the paint and they agglomerate. And here on the right, you see this whitish layer, and that means that components from lower of the paint migrated to the top and deposit. So the point I want to make here that, of course, it's extremely heterogeneous, but you also get a lot of mobility of small and large components to different areas in the painting. So that shows that if you see in painting, it might be chemically in an equilibrium, but if you change the climate or you remove a varnish layer and apply sulfate, you might change this equilibrium and start triggering some reactions or migrations, and that are for us a driving force to study that in Amsterdam. So that's a little bit how I see the heterogeneous paint systems. So if we go for oil paint research in preventive conservation, and why do we do that? We want to understand the impact of environment on the chemistry of paintings. And I would like to give you one case study where I think it nicely illustrates that the environment impacts the chemistry of painting. And that is here in the Hofkeshuis. The Hofkeshuis is in the east of the Netherlands, and this is a decorator's room where still the owners are living in, so they still have the central heating on and so on. But it's beautifully decorated with this brown tones, these wall hangings. And we investigated mostly on the art historical part, how they are made and what the meaning is, but it also gave me the opportunity to do some sampling. And what I've done, we took samples, cross-section from this brown line from the frame or the painted frame. And the hypothesis behind is that throughout the entire room, this painted layer would be the same, so have the same buildup and the same composition. So I took, I think, we will see later, about 15 samples throughout the room. And secondly, what we did in collaboration with the Technical University Eindhoven, on 4 spots in the room, we monitored or we measured the temperature and the relative humidity for a year. So the idea was to correlate the chemistry with the indoor climate. And this is what you get. So this is the painting what is hanging on the north window, in the north wall, and it's 7 meters wide. And the right side is close to the window here, and the left side is close to the door. This is 7 meters. So we took a sample between A and H, and it has 4 layers, and I highlight here layer 3 and 4. And what you could see is, and we did a lot of calculations on that layers, the paint close to the window is more saponified than the layer close to the door, the paint layer close to the door. This implies that the lead white pigment inside the paint reacted in this case close to the window more with the oil binder than close to the door. There the paint remains more intact. And when you put this in context, you see here the outline of the room. These are the windows. This is the north wall, what I showed you. This is the inner wall, and this is the outer wall on the south. So the light is coming from this direction. And A until R are the sample sites I took and sample and paint cross section. And the squares and the circles and the color are indicating the layer. So the square is layer 3 and the circle is layer 4. And I make 3 categories. So red means that it's completely saponified, orange halfway, and green that is semi-intact. And what we learned from it is that the paint, which we think it's all the same paint in the whole room, is more degraded, chemically reacted on the north wall close to the window, while on the south wall next to the chimney, it's better preserved. Well, and if you correlate it with the climate data, and this is a modulation, a control-based numeric model and reconstruction, and I plotted here the room. You see here already, indeed, the light and the temperature here falling on the north wall. So this is where the paint is more degraded, and on this side, what is cooler, it's more intact. Of course, the model is not optimal, and it's difficult to get exact numbers, and that was, of course, my ambition, because I was quite interested. If you see this chemical difference, can we say that there's an impact of a few degrees when this reaction is happening and not? So I was very curious, can we set a boundary where we get more reaction or not? But that turned out to be a little bit too ambitious, but this gives an idea. And here you see indeed a graph of the temperature in 1 month, where we concluded that in the point what is most degraded, here point A, there was the largest fluctuation in temperature and the highest average temperature at the surface. Well, of course, what you expect, where the paint was better preserved, it has the lowest fluctuations and the average temperature was lower. And it's only a few degrees, so it's very difficult to say, does this few degrees in average temperature affect the chemistry of the paint? But I think this case study is really an inspiration to go more in depth to investigate more reconstruction and controlled samples. So that's the bridge and make what we do in the GoGreen project now. And this is the project by Sander van Lith. He's a PhD student in the GoGreen. He makes a lot of reconstructions, linseed oil with different type of pigmentation. We artificially age them under high temperature, also with different relative humidity. And based on these different type of relative humidity, we look to the hydrolysis. So what you see, the aging in time, this is with infrared, the ester bond, and this acid bond. So if you get more hydrolysis, you expect that the ester is converted to the ester, and that's also what you're seeing. This is the aging time, 0 until 35 days, and you see indeed the ester band diminishing and the acid band occurring or dominating. And we try to get more kinetic parameters out of this to define these damage functions for this type of systems. These parameters also should feed a model. And that is developed by Jorien van Dijvenvoorde. She developed a one-dimensional moisture transport model based on vacuum diffusion, where we can see if we have certain climate condition, how will the water migrate into the different paint layers. So here she made a model what is mimicking, in our case, the night watch, where you have, of course, the varnish, the paint, the ground layer, the canvas, and the lining, the wax liningless material. And the question we had for her is, if we have the night watch hanging and we releasing our climate condition, do we get more water incorporated in the painting and thereby more reaction? So that's the thinking behind doing this model. And we plotted on this model also the measured climate conditions, the spectra we measured around the night watch in this model, and then we can detect the moisture content. And what she did, we took a lot of reconstructions, also real samples from night watch, and we did differential vapor absorptions, what tells us how much water it absorbed under certain relative humidity. And what you get out, and this is what is showing here, this is fresh wax resin, and this is the wax resin from the night watch, what we scraped from a remnant from the back. And what we do see in this graph, this is a differential absorption, and we do see that indeed the wax resin absorbs more water compared to a fresh wax resin, which of course is not that weird because it's more oxidized. But what this work is telling you, and I think that's interesting, so if we release the climate and we get more about, for instance, let's say here 70 relative humidity, does it matter? Does it absorb that far so that, or does it need to have a slow time before it absorbs into the painting? So that also helps in making a decision in your climate setting. If it needs to take hours before it's absorbed in the painting, then a fluctuation of half an hour does not matter. But if it absorbs very fast, then you need to take much more care about your environmental conditions. So this is a little bit how we do research to get more scientific support for decision making in preventive conservation. I would like to highlight now what we do for research in remedial conservation. And of course, we do that, of course, to understand the impact of the cleaning materials and methods on the chemistry of paintings. And thereby I take you with this concept. Here we have a systematic graph what the impact is on a varnish oil paint. And if you see here, this is the hypothetical paint, which is a varnish layer. So what is happening if you apply a solvent for varnish removal? Well, what you get your varnish is dissolved. You have another effect that your solvent is evaporating. It's diffusing into your paint. It can cause swelling. It can cause retention, so that means it stays into your paint. And it can cause a lot of chemical reactions, and it can cause leaching of smaller components out of the paint. And thereby you have to be aware, and that's also what I earlier said about this heterogeneous systems. And paint is not just a paint, it can be different compositions. So it can be highly bound, it can be a lot of cracking in there, it can be underbound so that it's very acidic and you can extract more components. So that is in every case different. So our question here is, how can we monitor the solvent absorption into the paint, and how can we take care that some less as possible solvent is penetrating into the paint? And to understand that, we used laser speckle imaging, and that is this technique. What we did in collaboration with the University of Wageningen, and now there's a separate spin-off company. And this technique is making use of a green laser, and looks at the interference pattern of motion inside the sample. So when you can imagine if solvents coming into the paint, this penetration initiates a lot of motion, and this motion is causing an interference pattern of your green light. And based on that, you can extract via Fourier transformation how long the solvent is in and what activity is and how it decays. And here you see my colleagues Laura van Herve and Lambert bij doing the tests on samples. And this is what you get. It looks like this old-fashioned black and white televisions. Here a droplet of ethanol is put on a zinc oxide paint film. And you see indeed the solvent penetrating through. And if you do a transformation, you see here a better way of presenting it. You see the droplet indeed spreading into the craquelure pattern, and you see the solvent evaporating. So that tells us a lot about what the solvent is doing and how it divides or how it's spreading into the paint layer. And based on that, we can do a lot of calculation. I see I'm a little bit short in time, so I'll go a little bit faster. So we can calculate how long the solvent remains in the paint, and that is what you see in this graph, for instance. So after 20 hours, there you still see some action in the paint. So it means that there's still some ethanol in this paint film. And why is it interesting for varnish removal? Is that here you see the graph of decay. So you see this movement, and the movement is decaying. And we put here an effluent tissue on a varnish layer. We place that 20 seconds, 90 and 300 seconds. Well, you can imagine, and that's the orange one, if you place a tissue with saturated ethanol for 300 seconds and you remove it and then you measure, then there's much more solvent in there than when you place it 10 seconds. And that's what this graph is showing you. So you see then more activity when you leave your solvent on your surface compared to shorter. And why is this interesting? How can you transfer this to cleaning? Well, if you take these points and we set them to exposure time, what you see, the red is just where we placed the ethanol with Avalon on a non-varnished paint film, and the black is with varnish. And at the moment the solvent is reaching the paint, you see this LSI vibration. So you're going to detect that as long as the solvent is the varnish, nothing is moving, so you don't detect anything. And that is interesting because what you see here on the black line, we don't measure anything. So that means that the solvent did not reach the paint layer yet and is still in the varnish. So based on this graph, you can determine how long you can put, for instance, your tissue on your varnish paint surface before it reaches your paint layer and starts to interact. And in this case, you would advise, for instance, to have 50 seconds or a minute, have the tissue on the surface before it's started to reach the paint layer. So this technology we also now apply to the night watch to understand how long we need to apply the Avalon tissues on the surface. And of course, I give the example now with ethanol, but of course, now we use a lot of other solvents like acetone, ethanol, but also more greener solvents to understand what their behavior is. This I skip. Getting back to this thinking model where we had a question, how can I monitor the diffusion of solvent and the distribution in the paint film, what we did at laser speckle imaging. Another way is, do we get indeed a leaching of components into the paint? And doesn't matter if I clean with a swab or a tissue or a gel. So that's what we did. We did some experience here. We made some systems. And I just do the other click here. Here they are 2-layer systems. We have a linseed oil where we added C17 fatty acid in. So that is a marker that is not originally present in the linseed oil. And on top of that, we add a linseed oil where there's some zinc in there. So a zinc polymer, as you can see. So you have a multi-layered system. So that's what we made. You can see them here, here, and here. And then we applied, or you see here, a tissue on top, or gel, or we cleaned with swab. And the thinking is that, do we extract C17 from this lower layer towards top? And doesn't matter if you use different cleaning methods. We analyzed these samples with SIMS, and why we did that, because it fantastically can detect the molecule, so you see 17. And this is what you get. You get these type of SIMS images. When it's very yellow light, there's a lot of component there, and when it's dark, it's not there. And I've plotted here your C17, what is our marker, the fatty acid C17. And this is the sample where we did not do anything, so it's clear that the C17 is still here in the bulk of the polymer. And when you apply, in this case, the tissue, the swab, or the gel, we can see that in all cases, the ethanol is penetrating through the layers, taking the C17 with extracting it through the top. And you do see that in this case of swab, there's much more extractant compared to, for instance, tissue, where it's more on the lower part of the paint film. So you can imagine that these type of analysis gives an idea about the impact of the technique, how to control your solvent release, and how that can affect the extraction of other components. But this I skipped because it just confirmed what we said is we verified the SIMS with mass spectrometry, where we detect the Avalon tissue, the gel, and the swab, and it's clear that when with the swab and also the Avalon, what is completely soaked, we extracted a lot of 17 fatty acid. And when you do controlled loading, and that's also what we advise, and you use the gel, you extract less C17, so you get less extraction of your fatty acid marker. Getting to the last part of the talk, defining green parameters. And here again, I want to come back to the manifesto, in this case, the second point, where we said a shared definition of greenness is our foundation. I think that is so important that we all need to speak the same language. And what is green? We also noticed there's a lot of discussion, what do we think is green, and what for me is green is not the same as my neighbor. So it's very important that we have this discussion and share our ideas and come in a way to a common sense. So within GoGreen, this is work package 8, where they work on the green efficacy and the green parameters. And this is mostly done by Gwen Vijf, Julia Wagner, and Katrien Southwick, where we want to eliminate greenwashing and advocate green conservation. And the goal is to make indeed a green definition standards and parameters. The strategy they applied, of course, we don't need to reinvent the wheel. So there are a lot of current definitions and uses of green related terms, but as a starting point, we or they investigate into the methodologies used in other industries, identify key impact areas. And I think what's important here, and that's why it makes our field different, is you need to include the complexity of the conservation decision and the applications. And that's why you cannot copy paste it from a paint company, for instance. You need to indeed put it in the context of your profession. And that legally present of parameters for their comprehensive application by conservators. So it's still work in progress, but I would like to share what we have so far. These are the green parameters that are selected by a large panel and the team. I'm not going to read them out to you, but I briefly group them where you see there are some parameters that have an impact on the hazard on human and environment, impact on climate change. You see here the energy, impact on resources. Do we get indeed, where do we get our components from, and what do we do with waste? And this is also very important for the profession. These are also parameters that are also related to the profession. The quality of the result is important, the accessibility and the number of applications. So there you see that they are developing within making this definition and these parameters within the context of our conservation field. And other work in progress, and I'm not going to read it out, not only time-wise, but also it's still working, is that we also work on a definition of a green conservation field. And if you are interested to play a role, think along, please contact me. I can bring you in contact with others, because I think this definitely should be a common effort where we all feel comfortable with and have a feeling that we identify in these definitions. So it's just to share with you that we are working on this. I'm getting to the end of the presentation, and I hope to give you a little idea what we do within the GoGreen project. And of course, we are not the only one working on it, but I think it's fantastic, a moment that a lot of activities are exploring. We in Amsterdam do a lot of more in-depth fundamental research on paint and paintings and their complexity to understand, as well preventive conservation, can release it, and the remedial conservation. And we are defining green parameters. And last but not least, I would like to highlight the first point in the manifesto, is that we all contribute to a green movement. And I think that it's really in our hands, and we really need to take ownership here. So that's why I think it's so good that this is the first point. Acknowledgement. I have a long list, but I've got many people, but I grabbed a few people of the work I showed from them. That's why I selected acknowledgement, but know that it's a lot of work behind with many, many people. And if you are interested in the GoGreen activities, please contact us via the website or follow us. And that is from my side. Thank you so much.
Thanks a lot, Katrien. It's been fascinating. What a large amount of research and interesting results. I'm sure there will be many questions. I'll ask one of my own while I'll give time to the speakers to type theirs. I'm very interested in this development of damage functions for paintings, especially because it's such a difficult problem. One thing that fascinates me is all the chemistry that's going on behind the surface. And I wanted to ask you what external expression this chemistry has usually. Like how does it translate? What you observe at a microscopic level, how does it translate in appearance of the paintings? At what point what you can detect becomes a concern that would make the painting less aesthetically valuable or would affect, its historical interpretation and so on?
That's such a nice question, because why does it matter? Correct. That's also what I hope to show with the case study of the Hofkeshuis with this interior, where you saw these different chemical reactions, that and I didn't show the details, but where it's completely degraded in chemical reaction, it's fully cracked. So it's very sensitive. And other areas that become more transparent. So although you see a certain chemical phenomenon or reaction, depending where it's expressing differently. So that is one thing. A question I have, for instance, with this wax resin lining, and that's why we do a lot of studies. And that is also, it's holding the painting, so it's constructural, very important. So for wax resin lining, you need to understand how does it degrade and how can it last, because within 100 years is all our collection falling from the wall. Of course it isn't, but I really want to understand how can we predict indeed chemical behavior, and we need to correlate it to mechanical behavior, because that's a key here, to be indeed having models to have better predictions here. So it's indeed, there's no one answer to your question, and but it really manifests in different ways depending on what the paint composition is, where it is hanging, and these type of things. Yeah.
Absolutely.
Yeah, thank you.
We have a question from Katrien Keune, associate professor at ISH. She says, when you mention recycling conservation materials, does this mean reusing them or putting them in recycling waste? If they are reused, has the Rijksmuseum got any guidance as to how many times it's appropriate to reuse materials before they reach the end of their useful lives?
Yeah, that's also a very good question, of course. This is not my task, but what I can say is that when we have exhibition, we try to develop the exhibition cases such that we can use them for more exhibitions. So that's the design of the exhibitions are they have more general guidelines so that we can reuse cases. What we have, for instance, is that all the banners what are on the building, they are sort for suitcases for moving the painting. So they are indeed cover slides. I don't know if I say it correctly, for transport. So that's why they reuse material for other functions. I know that with all the curtains from the Vermeer exhibition, but were a lot, these beautiful velvet curtains, they produce a lot of bags, what they are now selling in our shops. So they have different ways of recycling the material. So it's different purposes, of for exhibitions and loans, or we try to design that we can reuse it. So it depends on what type of material it is. And also with repainting, it's also carefully thought that with exhibitions you don't not always need to completely repaint everything. So there's a lot of thinking behind it, and every time we do a new step where we aim to improve the exhibitions.
Thank you. We have a very interesting question from Natalia Politilo Aluvihare, who is an undergraduate chemistry student at Imperial. She asks, considering the uniqueness of each painting and the heterogeneity within the paint system, how are your findings currently being used at the Rijksmuseum, or how do you anticipate their implementation in preserving the museum's entire collection, specifically addressing environmental considerations, which is, if I may add, the fundamental problem of heritage science. So it's a very astute question, Natalia. Thank you. Let's see how Katrien can tackle it.
Yeah, I'm curious how you will tackle Joseph in that case. Yeah, it is a fantastic question, and that's also what I, of course, highlighted in the presentation, how heterogeneous it is. But still, I really believe there are red threads, and I think that's where our research focuses on. For instance, hydrolysis is one of the key mechanisms, how you get indeed fragmentation, or you see a lot of migration of fatty acids or crust formation on surfaces. So there are a lot of mechanisms where they are really in all paintings the same, and these are what we try to understand. And if you understand indeed, if we move across, for instance, will it come back, yes or no? That helps indeed decision making in conservation. And also now with cleaning paintings, it really helps. Should we use acetone and ethanol? Of course, the behavior is leading. But the decision, how long do we use a tissue on it or not, it really helps in decision making. So we always take the general topics and try to understand the trends and the behavior. And of course, the discussion with the conservator and the scientist have to make the link to the objects in case by case. And that's, of course, a benefit working in a museum, that you have this dialogue, so that because we are not separated identities and we collaborate, you can do more the fundamental research and the red threads and translate it to a case-by-case study. And I think that mechanism helps each other very much. I hope that answers your difficult question a little bit.
Excellent. Thanks a lot, Katrien. And with this reflection, we could leave it here. It's already 1 hour. And I'm sure we could keep discussing because it has been absolutely fascinating. We have had one last comment from Katrien Keune that says, thank you for a wonderful talk with fascinating chemistry. And I couldn't agree more. So thanks a lot, and I hope to see you soon. There will be another ISH guest lecture, and in June, the details will be announced very shortly. I'll see you all then.